बस ये जिंदगी है, अब क्या ही कह सकते हैं. Have I started the recording? Yes, I've started the recording, and God knows why my AirPod is not connected. Wait a second, let's connect this AirPod and look a little Gucci. Yes, yes, yes. Can I have a Gucci in the chat box? Sir, because of you, titration is gupshup. Yeah, I know it's gupshup, but a lot of students haven't studied from me, and this is, just a final push for all the other students who struggle a lot in titration and long ATP questions. So we have to look into it for all the others. And now it's connected. I don't know why I like to wear the what's it called? I don't know why I like to wear the AirPods, although I've not given you guys permission to mute unmute yourself, but hey. इतनी ज्यादा रीडिंग ऐसे ही होता है. Just give me a moment, let me charge my AirPods pod. Yeah. Charge this quickly and then we'll start. Acha, today's class is very important because I think let me move closer towards the mic. I think that titration may come in your paper. I don't know. I just have a gut feeling. It's either titration or it's going to be a graph question like rate of reaction or chemical change, chemical reaction, which is like, temperature change. Mm, mm. No, 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 no. Okay, okay, okay. Yes, can I get a yes in the chat box? Yes, hopefully I'll try to upload it onto YouTube as well. Try to. Yeah, but it will be uploaded. Sir, is this your background wall? I know it looks nice. Acha ji, so we're going to look into titration questions, and I've already shared the entire booklet with you guys, the 15-20 pages workbook with you guys in your respective groups. And if you don't have it, you could just go on to Conceptuals Academy, look into the story, and you will have the link there, and you could access this book, right? It's just a 15-16 pages booklet just to try to help you guys navigate your way through titration questions if they were to come in your exams, right? Now, before we look into this question, I want to just make sure that you guys know why we do titration. So before we look into this question, usually the reason why titration is performed is it's an experiment which helps you find out the concentration of an unknown solution with the help of a known solution, right? A known solution with help of a known solution. And titration is, just a fancy word of conducting an experiment. It's just a fancy word of conducting an experiment. And what we do here is I'll just give you guys the general thought process behind it, and then we'll start solving questions. The general thought process behind titration is that you use in our course is usually acid based titration, and what we realize is that we know the concentration of a particular solution. Like for example, I know the concentration of an acid. Let's suppose I went to my laboratory and I opened the laboratory cupboard, and I found out that I had hydrochloric acid and it had a concentration of, let's suppose, 1 mole per dm cube, right? Let's suppose. And then I wanted to find out how much concentration was for a solution of sodium hydroxide, right? So I wanted to find out how concentrated sodium hydroxide solution was, and I took, like, 25 cm cube of sodium hydroxide in a conical flask using a pipette along with a pipette filler, right? So I poured it right here, and then I want to find out, and that's hydrochloric acid. Now I want to find out the concentration of sodium hydroxide, which is my unknown solution, with the help of the known solution, which is hydrochloric acid, right? And the experiment that you perform when you have a known solution, the concentration of a known solution right here, and to figure out the concentration of an unknown solution, that's literally called titration. And the entire idea behind titration is to find something called the volume for endpoint, right? Or the volume of endpoint, or the volume of neutralization. That's the volume that you find out, when the indicator, this is indicated by the change in the color of the indicator. So when the indicator changes color, you'll realize that that's the volume of utilization for your level, or you could say that's the volume which was required to neutralize 25 cm cube of sodium hydroxide. Effectively, that's the end point, right? So the entire idea behind conducting the titration experiment is to figure out the volume of the known solution right here, the volume of the known solution right here, how much of 1 mole per dm cube of hydrochloric acid was required to neutralize sodium hydroxide. That's the entire idea behind titration. And once we have this volume, we could figure out the concentration of the unknown solution, which is sodium hydroxide. How do you do this? Let's suppose I found out that 21 cm cube of HCl was actually used, let's suppose, right? Or, you know, let's change it from 21 to maybe 20 cm cube. So let's suppose I say that 20 cm cube of hydrochloric acid of 1 mole per dm cube was used to neutralize this beauty right here. And the way it helps us in calculating the concentration of the unknown solution is that we could take the concentration of the known solution and the volume of neutralization, or the volume that was required of this particular known solution, and you could calculate the moles. So what do we do? The first step that we do after we conduct the entire experiment to find this volume right here, the first step that we do is to find out the moles of hydrochloric acid that were actually utilized, right? And you could find that out by a simple formula: N is equal to CV. You have the concentration, and you also have the volume right here converted into deciliter cube, and you'll find the moles of hydrochloric acid. And then from the moles of hydrochloric acid, you don't want the moles of hydrochloric acid. What do I need? I need sodium hydroxide moles, right? So from the moles of hydrochloric acid, I use the equation to jump from the moles of hydrochloric acid to the moles of sodium hydroxide. That's the equation that's given to me. And from the ratio in the equation and these moles right here, I find out the moles of sodium hydroxide. And once I figure out the moles of sodium hydroxide, let's suppose that's maybe 0.8 mole per dm cube. I'm just assuming, that's 0.8 moles. So let's suppose the moles of sodium hydroxide used was 0.8 moles. Then you could easily calculate the concentration by taking these moles and this volume and using the same formula: N is equal to CV. You have the moles now, you have the volume that was present right here in the conical flask, and then you could find out the concentration. So that's the entire idea behind titration. You need to know this thought process to be able to solve every single question for titration. What's the thought process? The thought process is that titration is basically an experiment that is carried out to find the concentration of an unknown solution with the help of a known solution. And how do we do that? Well, we know that hydrochloric acid, or it can even be an alkali, right? So, but for example, in this case, we'll take hydrochloric acid as our known solution. So hydrochloric acid has a particular concentration, and that's written on the bottle of it when I went to, take it out of the cupboard in the laboratory, right? So I took out that concentration of hydrochloric acid, and I performed the entire experiment for titration in order to figure out how much volume of hydrochloric acid, how much volume of this known solution was needed to neutralize this much volume of sodium hydroxide. So once I got the volume of hydrochloric acid that actually neutralized this stuff, I used this volume and this concentration to find the moles of hydrochloric acid. I used the equation which gave me the relationship between hydrochloric acid and sodium hydroxide to figure out the moles of sodium hydroxide after this. And then after I got the moles of sodium hydroxide, I had the volume, I found out the moles, and that's how I can find out the concentration of sodium hydroxide, right? How do I know the ratio? From the equation. The equation will always be given to you in ATP questions, right? Although you need to be able to write down these equations. अच्छा जी. Now let's look at these questions. That's the entire thought process. अब हम एक एक सवाल को dissect करते हैं. अगर ये thought process आपको आ गया, बाकी सब कुछ हल है. अब देखते हैं. Aqueous ammonia, which is NH3 aqueous right here. Aqueous ammonia is a solution of ammonia gas. A student titrates two samples of aqueous ammonia A and B with 0.5 mole per dm cube of hydrochloric acid. What does this mean? This is our known solution, right? That's our known solution. And what you need to realize is that from the entire titration experiment is carried out. Why? Why is the entire titration experiment going to be carried out? To figure out the volume of hydrochloric acid used. Because once you figure out that volume, you could use the volume and the concentration to figure out the moles of HCl, use the equation to go into the moles of aqueous ammonia. And once you have the moles of aqueous ammonia, you've used 25 cm cube of ammonia, right? Aqueous ammonia. So you have the moles, you have the volume, figure out the concentration. That's it. That's the thought process. बार बार एक दो दफा अपने जहन में ये thought process revise करें. So once you have the known conc, You could use the known conc right here, and you figure out the volume of neutralization through titration, and you use these two values to figure out the moles, use the equation to find aqueous ammonia, and then once you have the moles of aqueous ammonia, you also have the volume, you'll figure out the concentration. That's literally the entire thought process, and you'll see the entire experiment will revolve around this idea, always, 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 because that's literally what it stands for. ठीक है जी? अच्छा, so and why would he be using aqueous ammonia A and B? Why would he be using A and B? Probably he wants to figure out okay, which of these is more concentrated, right? And one more question from my end. I have a question from my end. Let's suppose you had the acid in the burette, right? And this question has not been tested recently, but it can be tested, right? So let's suppose I had the acid in the burette, and for when I perform titration with aqueous ammonia A, I performed titration with A, I figured out that the volume of hydrochloric acid that was used was, let's suppose, 21 cm cube. But with B, when I performed the same experiment with B, the volume of hydrochloric acid that was used was maybe 26 cm cube. Which of these is more concentrated? Is B more concentrated or is A more concentrated? Which of these is more concentrated? Is A more concentrated? Is aqueous ammonia A more concentrated, or is aqueous ammonia B more concentrated? And it's a simple question, but because people don't use their common sense, they get it wrong, and a lot of students are getting it wrong. And that's the reason why I'm here to teach you. You realize that A and B, I want to figure out which of these have the higher concentration. I already know the concentration of hydrochloric acid is 0.1 mole per dm cube. I already know that. But in one scenario, when I was reacting this much, the same hydrochloric acid with A, it took 21 cm cube of hydrochloric acid. But with B, it took 26 cm cube of hydrochloric acid. And A and B are both the same volume. Huh? आपने pipette से you've poured 25 cm cube of A and 25 cm cube of B. Now use your common sense. If in one case 21 cm cube is used to completely neutralize this, and in the other case 26 cm cube of acid is used to completely neutralize this, what do you think is more concentrated? Is A more concentrated or is B more concentrated? See, B is using up more acid. B requires more acid to be neutralized. So those of you who are saying A are absolutely wrong, because B is requiring more acid to be neutralized. B says I need 26 cm cube of acid. In order to finish me, I need 26 cm cube of acid. I need more acid. That means I'm more concentrated. But if you talk about A only needs 21 cm cube of acid. So if it needs 21 cm cube of acid, that means A requires less acid to completely be neutralized, and B requires more acid, the same amount. Both are 25 cm cube, but one requires 21 and the other requires 26. So obviously the one that requires more acid is more concentrated. So those of you who are saying A, revise all your concepts, right? But there's a catch to it. What if I flip the situation? Now think about it. What if I flip because students then tend to start rote learning this. Don't rote learn it. Use common sense. What if I flip the situation? What if at the top I put A, and then at the top I use B, and at the bottom what I do is I add hydrochloric acid with a concentration of 0.5 mole per dm cube, the same thing, and that's 25 cm cube. How do I know it's 25 cm cube? Because I used a pipette to pour hydrochloric acid inside this conical flask. Yeah. But wouldn't A be more concentrated because it requires more of it to no, A is the same. A is 25 cm cube, Shamin. B is also 25 cm cube. A and B are the same amount that you've used a pipette to pour this right here in the conical flask. But A requires 21 cm cube of acid, which is less compared to 26 cm cube. B requires more acid to be neutralized. So B is more concentrated because in order to finish 25 of B, you need 26 of 26 of hydrochloric acid. And in order to finish 25 of A, you need 21 HCl. So, A requires less HCl, B requires more HCl. to be able to, you know, be totally neutralized. So B is more concentrated. Yes. But Shamin, if I flip the situation, now I want to find out that, you know, I've put A at the top and then B at the top, which is unknown, and I want to find out whether A or B, which of these is more concentrated, right? Now, if I want to figure out which of these is more concentrated, I'll give you some values. I'll say, hey, in this case, A was 21 cm cube. In order to neutralize 25 cm cube of hydrochloric acid, you require 21 cm cube of A, and for B, it required 26 cm cube of B. Now, is A more concentrated or is B more concentrated? Yeah. Is A more concentrated? Don't put a question mark, Zara. Come on, use common sense. Now, see, now I fixed HCl. HCl is 25 cm cube. Now, in one case, 21 of A were required to completely finish this off. But in the other case, 26 of B's were required to finish off 25 cm cube of hydrochloric acid, which means that the lesser amount A which was being required was less compared to B. A was only 21 for this 25 and B was 26 for this 25. So you required less volume of A, which means A is more concentrated here. Why is A more concentrated? It's more concentrated because less volume of A was required to completely finish this, and more volume of B is required to completely finish this. So A is more concentrated. Remember, you need to just figure out what is at the top and what is at the bottom. So once you figure this out, the titration experiment becomes pretty easy, right? So now we just have to figure out what's in the burette and what's in the pipette. In order, see, these are golden things that I've told you at the start of this class. This will dictate your entire titration experiment. ठीक है जी? अच्छा जी. So he's saying he does 4 titrations, 2 with A and 2 with B. He rinses and fills up the burette with 0.5 mole per dm cube of hydrochloric acid. Now, my question to you guys is, why does he rinse the burette? Why does he rinse the burette? He rinses the burette, why? In order to clean it, obviously. But the question is not just about cleaning it. Please realize it's not just about cleaning it or to remove it from, or to remove impurities from it. It's not just about removing impurities from it. Think about it. He rinses and fills the burette with hydrochloric acid. So he's effectively rinsing it with hydrochloric acid. Why is he rinsing it with hydrochloric acid? Please, these are golden things that I'm telling you, and it will be, the examiner will ask these things. Has anybody thought, why is he rinsing it with hydrochloric acid? Why is he rinsing the burette with hydrochloric acid? Why not just with distilled water? Yes, Aisha, that's absolutely right. You're right. Yes, Shahid, you are right. Yes, you all are right. Yes, yes, yes. So what you need to understand is, if he just rinses it with distilled water, obviously he removes impurities, right? He removes contaminants from this burette, which may have been present due to previous experiments. But the problem is that once you wash it with distilled water, there may be some water droplets that would be left behind at the end, right? There may be some water droplets from the distilled water which may have been left behind inside a burette. The burette it has a very small opening, right? So you can't put a kapra inside of it. So then what do we do? If you directly put hydrochloric acid inside this and then you perform your titration, you'll realize that you thought that the hydrochloric acid was 0.5 mole per dm cube. You thought that it was 0.5 mole per dm cube. But in reality, because of these water droplets, the hydrochloric acid is no longer 0.5 mole per dm cube. Rather, it's diluted, right? So if you've added more water droplets, the denominator increases. 1 dm cube is just 1 liter. So the denominator increases from 1 dm cube to a little more than 1 dm cube, which decreases the numerator, right? So now maybe you no longer have 0.5 mole per dm cube of hydrochloric acid. You would have a lower concentration. So what happens is that these water droplets dilute the concentration of hydrochloric acid. These water droplets dilute the concentration of hydrochloric acid. So in order to prevent the dilution of hydrochloric acid, the dilution of concentration of hydrochloric acid, you also have to wash it with hydrochloric acid after washing it with distilled water. Make sense? Make sense, everybody? मजा आ रहा है? देखो, एक दफा चीजें समझ आनी लग जाए तो बड़ा मजा आता है, बड़ा मजा आता है, right? So you need to wash it. And I have a question from you guys. देखो, if the hydrochloric acid gets diluted, how much will the volume of neutralization increase or decrease? Will the volume of, let's suppose, if you used 0.5 mole per dm cube of hydrochloric acid, exactly 21 cm cube of HCl was going to be used, right? But now it's a little diluted. So the strength of hydrochloric acid decreases, which means more hydrochloric acid would be needed. All of these can be tested in your exams, especially IGCSE students. ठीक है जी? अच्छा जी. Done, sir. So he rinses and fills up the burette with 0.5 mole per dm cube of hydrochloric acid. Now we know why does he rinse it with hydrochloric acid? To ensure that the concentration of HCl does not get diluted. Make sense? Now it says use a volumetric pipette to add 25 cm cube of A to a conical flask. So he's first figuring out A, right? So he took the volumetric pipette and he added 25 cm cube of A to the conical flask, right? And why did he use a pipette? Why not a measuring cylinder? Because a pipette is more accurate than a measuring cylinder. Although a pipette takes longer. So the disadvantage of using a pipette is that it takes longer compared to a measuring cylinder, but it's more accurate than a measuring cylinder, right? Acha, my question to you guys is this setup number 1 or is it setup number 2? This is setup number 1 and that's setup number 2. Which of this has the examiner done? Is it setup number 1 or setup number 2? It's obviously setup number 1. He put the hydrochloric acid in the burette, which means that if I now say, hey, more hydrochloric acid was used, if I figure out, in for A, 25 cm cube of hydrochloric acid was used, and for B, 30 cm cube of hydrochloric acid was used. Which one is more concentrated, A or B? Which one is more concentrated, A or B? Because hydrochloric acid used is more for B, that means that B is more concentrated. Yeah, because it takes up more hydrochloric acid. You just have to figure these short things out. मजा आ रहा है, मजा आ रहा है. चलो, that's awesome. I'm glad. सर इतनी क्लैरिटी से पहले किसी टीचर ने नहीं पढ़ाया. चलो, I'm glad. Yeah, I'm glad. मेरे से 500 स्टूडेंट्स की आप लोगों ने सब्सक्रिप्शन ली और अब सारे इंडिया पाकिस्तान का मैच देख रहे हैं. अच्छा, यूजेस अ वॉल्यूमेट्रिक, ये हर दफा होता है जब 100 स्टूडेंट्स हो जाते, सर ज्यादा सब्सक्रिप्शन ले, 100 से ज्यादा, ये वो एंड देन व्हेन वी गो अबव 100 आई स्पेंड $50 एंड देन दैट्स व्हाट हैपेंस. स्टूडेंट्स देन आर लाइक, सर पे सब्सक्रिप्शन ले लिए, बस ठीक है, यूट्यूब पे देखेंगे बाद में. या बस एग्जाम की रात से पहले होना है. चलो, लेट्स सी. अच्छा, खैर, he uses a volumetric pipette. See, in the ATP the most important thing is to figure out the question, read the question carefully. बस आंसर में टाइम नहीं लगता. Pipette takes more of what? Pipette takes, I've never said pipette takes more of what. I just said it takes longer to use a pipette than a measuring cylinder, but a pipette is more accurate than a measuring cylinder. Okay. Then he says he adds 5 drops of methyl orange indicator to the conical flask. So if I add 5 drops of methyl orange indicator to the conical flask, what should be the color? Methyl orange is an indicator which gives you a red color in an acid or in an acidic solutions and yellow in alkaline solutions, right? So what color should it be? Obviously, we know that A is aqueous ammonia and ammonia is a weak base. So obviously, yellow would be the color that I'd see with methyl orange because obviously it's an alkali. Acha ji, he places the conical flask on a white tile. Why would he place the conical flask on the white tile? So that the color change is more clearly observable, right? Or you could say to observe a clear endpoint. That's also absolutely correct. So the color change is clearly observable. Color change is more clear, or is clearly observed, whatnot. Then he adds 0.5 mole per dm cube of hydrochloric acid from the burette while swirling the contents of the flask. So why is he swirling the contents of the flask? He takes the conical flask or the Erlenmeyer flask and he starts swirling it, right? So why does he swirl it? Obviously to not to evenly divide the heat. Muhammad Ali, you are right, but that's not the purpose of swirling at this point because we don't care about heat. We don't care about heat at this point. I'm not doing this experiment to find temperature change. If this was an experiment to find temperature change, I'd say that. But for now, I just want to mix the reactants thoroughly, right? So to mix the reactants thoroughly, that's what I want to do with it. because my goal is not to measure temperature change. So why would I write to evenly spread the temperature or the heat? Yeah. Acha ji. And now he thinks he adds drop by drop. He adds a drop by drop near the end point until the solution changes color. When the solution changes color, that means that the end point has been reached and you need to stop your experiment, and record the volume of acid that was used. Done. So my question to you is, why is he adding a drop by drop near the end point? देखो common sense से चीजें सोचा करें. Why is he adding a drop by drop near the end point? To not overly add the drops, or how do I put it in proper English? To not add more drops than required, right? Because if he adds it, if he opens this tap really fast, what could happen is the time that it takes him to close this tap, excess drops may have fallen inside the conical flask. So he would have not, he would get an overstated value for the volume of neutralization. To not add excessively. Yes, to not add excessively, right? Achha, वैसे my question to you guys is, what if he adds more drops? Would it overstate the volume of neutralization or understate the volume of neutralization? Yes, for accurate endpoint, that's also correct. Yes, he would actually overstate it. No, why would he understate, Ali? He would overstate it because required might have been 21 cm cube, but because he added it too quickly, it took him longer to turn off the burette tap, and he might have added more than 21 cm cube. He might have added 25 cm cube, 26 cm cube. So to ensure that the endpoint is accurate endpoint is observed, that's that the volume of neutralization or the volume for the endpoint is accurate. That's why he's adding a drop by drop. Acha. Now he says he empties the conical flask and rinses it with distilled water. Now, why is he rinsing the conical flask with distilled water? To remove impurities, obviously, to remove contaminations from experiment 1. And he repeats the step 2 to 6 again, obviously. And then he repeats step 2 to 7 using aqueous ammonia B instead of A. So he does all of this twice, and then he uses aqueous ammonia B instead of A for the other 2 titration experiment, right? Done. Now let's look into the questions. बस ये पॉइंट्स बहुत बहुत गौर से पढ़ने हैं आपने, बाकी सारा हलवा है. अब देखिए figured. अच्छा, वैसे my question to you guys is, all of this experiment was for what? All of this experiment was for what? Was for this beauty right here, this beauty, to find out the volume of hydrochloric acid used. Acha, no. He's saying he didn't rinse it with hydrochloric acid. Fatma Singh said, but he didn't rinse it with hydrochloric acid. The concentration might have changed. No, he's rinsing, the hydrochloric acid is in the burette. He's rinsing the conical flask, which contains sodium hydroxide. Yeah? Yeah, and you don't have to wash it with sodium hydroxide after you wash it with distilled water, because you'll realize that even if water is present, sodium hydroxide that you're using is 25 cm cube. So even if water droplets are present inside a conical flask, hydrochloric acid would only react with the particles of sodium hydroxide. They would only react with the particles of sodium hydroxide. So it doesn't matter if the water molecules are present in the conical flask. Yeah, so you don't have to wash it with sodium hydroxide after washing it with distilled water. It wouldn't change the moles of NaOH. Yes. Acha khair. Figure 2.1 shows the burette readings for 2 titrations with A. So if you check out, that's the initial reading, that's the initial, you just read it at 0.0, and the final reading is right here. That's 15, 15.1, and that's 15.2 right here. So that's 15.2. And then for titration 2, you have 15.2 as the initial reading. That's how you started off with it. And then it's 30, 30.1, 30.2. That's awesome, right? So I'll just write it here. The initial, please don't mess this up. Initial burette reading for titration 1 was 0.0. The final was 15.2. Please read what's written on the left-hand side before writing here, And then in this case, the initial was 15.2 and the final was 30.2. Is that correct? Absolutely. अच्छा, आसान है सर, बहुत आसान है. अच्छा, awesome. अच्छा, so what do you get? The volume used 15.2 and the volume used here is what? 15.0. Yeah, 15.2 and 15.0. Now, my question to you guys is, sir, isn't burette reading restricted to, no, it's still 1 dp here. In centimeter cube, you just need to write it till 1 dp. It's 3 sig fig 1 dp. बल्कि 1 dp का 3 sig fig ना कहें क्योंकि फिर ये 0.00 होता. It's just 1 dp. Achha, my question to you guys is, what is this volume? What is the volume that you figured out? Obviously, it's the volume of hydrochloric acid that was used. That's the volume of hydrochloric. The burette reading is basically showing you the volume of hydrochloric acid. You remember the thought process. It will follow this thought process throughout. So, the volume of hydrochloric acid used for A is 15.2, and then for B, that's 15.0. Now, my question to you guys is, which of these two are more concentrated? Which of sorry, this is for A. These are both for A, my bad. These are both for A. Yeah, these are both for A. That's for A, my bad. For B, you have to look at the other two experiments. That's for B, that's the titration with B. So he says, record the burette readings for titration 4 in table 2.2, complete table 2.2 with the volume used in each titration. So let's look at this. Titration 3 is already given to us, and titration 4 we have to figure out. So it's 0, 0 0.1, 2, 3, 4. The one that comes out a little other than these, that's 0.5, so that's 0.4, that's 0.5, and that's 0.6. So that's 0.6 right here. That's good enough. And then here, that's 35, 35.1, 2, 3, 4, and then that's 35.5, So for titration 4, the initial reading is what? The initial reading is 0.6, and the final reading is 35.5 Reno. Then, can you guys tell me the volume used? Just subtract the two, final minus initial. Final minus initial. What do we get? 34.7 and 34.9. Now, that's the volume of hydrochloric acid. Remember, that's the volume of hydrochloric acid used to neutralize 25 cm cube of B. अपनी भी annotations किया करें, right? And that's the volume of hydrochloric acid, that's the volume of hydrochloric acid required to neutralize 25 cm cube of A. Now, in one case, 15 cm cube of hydrochloric acid is being used to neutralize A, right? And in the other case, 35 cm cube of hydrochloric acid is being used to neutralize the same amount of B. Which of these is more concentrated? Is A more concentrated, or is B more concentrated? No, Shahid, why Raima? Why A is more concentrated? In one case, you need 25 to neutralize 25 cm cube of A, you only need 15 of hydrochloric acid. But in the other case, to neutralize the same amount of B, you need more of hydrochloric acid. So B is more concentrated. Come on, ओके साउंड्स गुड अच्छा मेरा सवाल है कितना ज्यादा कॉन्सेंट्रेटेड है चलो उस पे आ जाते हैं देखो you could just take the ratio between the volume so if the average volume used here is 34.8 and the average volume used here is 15.1, just divide the two to find out the factor that tell you how much more concentrated it is. Here, explain why the student uses the white tile. Pretty easy. Why does the student use the white tile? So 30 minutes and this is the best class of my life. Awesome, Fiza. Have you never joined the classes before this? Okay, that's awesome. I'm glad. So why do you need a white tile? Obviously to observe the color change or the endpoint more clearly, whatever. Doesn't make a difference. Or you could say the endpoint more clearly. You could fix the English, but the idea, or accurately or whatnot, whatever, doesn't matter. For better observation, whatever you write is fine. Acha, calculate the mean volume of hydrochloric acid. Calculate the mean volume of hydrochloric acid needed to neutralize 25 cm cube of A and B. So how much mean? We have to just calculate simple mean. How much of hydrochloric acid was required? The mean volume. So how do you calculate mean? These are two volumes and you just divide them by 2. So 15.2 plus 15.0 divided by 2. That's 15.1 cm cube is the mean volume of hydrochloric acid that was required for A. And for B, it's 34.7 plus 34.9 divided. Yes, mean is the average, simple average. 34.8. Now, my question is, you guys yourselves have said that B is more concentrated, B is more conc than A. Because why? Why is B more conc than A? You could even find out the factor because it requires more volume. It requires a larger volume of HCl to neutralize the same amount of it. Now, my question is how much larger? Approximately how much? You could just take the ratio between the two, Oh, my bad. I'm so pathetic at drawing, You could just take the ratio 34.8 divided by 15.1. जैसे मर्जी करनी. So it's almost what? It's almost more than double. It's almost more than double. 2.3. So it's almost, 2.3 times more concentrated. B is almost 2.3 times more concentrated than A. Pretty easy stuff. Almost 2 times more concentrated. Yeah, almost 2.4, 2.3 times more concentrated. Done. Achha, the equation for the reaction. Ab dekhiye, you figured out the volume of neutralization. Now, he'll ask you to use the volume of neutralization as well as the conc of hydrochloric acid to find the moles of hydrochloric acid. And from the moles of hydrochloric acid, you are going to be required to find the moles of aqueous ammonia. From the moles of aqueous ammonia, you'll be required to find out the conc of aqueous ammonia, because we know the volume, that's 25 cm cube, and the conc you could easily figure out. Sir, so when we talk about the solution being more concentrated, is it from the perspective of HCl used? No, Shahid, I said it at the start of this class. There are two ideas to it, and you should rewatch the recordings to get these two ideas, because it's all dependent के ऊपर क्या है नीचे क्या है. Acha. The equation for the reaction is shown. Use the mean volume of acid needed to neutralize 25 cm cube of A in D. And he also, he basically holds you by the finger, and he takes you throughout, he guides you throughout the questions. So he's saying to neutralize 25 cm cube of A in D, to calculate the concentration of aqueous ammonia, and mean volume, we need to use A. A's mean volume. So what was the mean volume of A? That was 15.1, right? It's called, in finance, because I'm a chartered accountant by profession. So in finance, we call this profiling. So you need to write for yourself what's given to you. So I'm going to use A, which is 15.1 cm cube. Profiling is just writing the data for yourself. And what's the concentration of, that's the hydrochloric acid, right? The volume of hydrochloric acid used in A. And what's the concentration of hydrochloric acid? That's given to you, 0.5 mole per dm cube. And you could use these two to find the moles of HCl, use the equation to find the moles of aqueous ammonia, and then use N equals CV to find the concentration of aqueous ammonia, because once you have the moles, you also have the volume, and boom, shaka laka, you're going to get the answer, right? So N is equal to CV. Moles kitne? We have to figure that out. Concentration is 0.5, volume is 15.1, but please realize that these units are not the same. One is cm cube, one is dm cube. Dm cube is basically liters, and that's milliliters. So I have to convert the milliliters into liters by dividing it by 1,000, That's it. And if these two units are the same, then you don't need to do anything because they cancel out. Acha ji. So what do we get? N is equal to 0.5 multiplied by 15.1. Divided by 1,000. What do we get? 0.00755. So 0.00755. Dekho, that's the thing. You guys don't keep in mind the question. Some students saying, sir, how do you know it's 0.5 mole per dm cube? Bilkul shuru mein likha hua. That's why I say write it for yourself. That's why I gave you the entire idea. That's here, 0.5 mole per dm cube. The only problem with these questions, because they're lengthy and you guys don't write stuff for you and for yourself, and you guys go over the questions, skim over the questions. That's the problem. Sir, why did you do divide by 1,000? Oh, kill me. Don't worry. I'll tell you. 1 dm cube equal 1,000 cm cube. So if you have a 15.1 cm cube, how much dm cube would it be? Cross multiply. X is equal to 15.1 divided by 1,000. That's how I got it. That's how I got it. But chili on the track. That's how I got it. Khair, once you got the moles of, what are these the moles of? Please realize, write it for yourself. That's the moles of hydrochloric acid. Now use the equation to find the moles of ammonia. 1 mole of hydrochloric acid reacts with 1 mole of ammonia. So if 1 mole reacts with 1 mole, 0.00755 would react with the same amount, 0.00755. These are the moles of aqueous ammonia. And once I have the moles of aqueous ammonia, I also have the volume. So N is equal to CV. I have the moles, which is 0.00755 divided by the volume. But realize the volume is in cm cube, and the answer that the examiner wants is in dm cube. If the answer that he wanted was in cm cube, then you would just divide it by 25, but he wants it in dm cube. So convert this cm cube into dm cube, divide by 1,000, So once you divide by 1,000, what do you get? Andy, 0.302. Sure? 0.302. Can somebody confirm, please? 0.302, sure? Mole per dm. No, it's not important to write this because you could just see it from the equation. It's 1:1, so this would be the same as this. It's just, a systematic way of going about it, Junaid. So you don't need to write it. It's a 2-mark question. अच्छा यही आ रहा है चलो awesome. So that's the concentration for aqueous ammonia A. याद रखिएगा मेरा एक सवाल आपके 10 सवालों के बराबर है, तो कोई टीचर शायद मार्केट में ऐसे टीचर्स हों जो बस जल्दी जल्दी 10 सवाल करा रहे हों और जान छुड़ा रहे हो, ओ भाई ये तो सिंपल है, मेरे 2 सवाल मैं कराऊंगा आपको, इट विल कवर एवरीथिंग, फिर आपने खुद करना है. Question 4 hopefully tomorrow we'll do question 4, and then day after tomorrow we'll do question 2 part B, which is part B is basically he can either test titration. देखो examiner is confined to the syllabus. मैं आपको अभी से बता देता हूँ आपके पेपर में क्या आ रहा है. सर आपके पेपर में क्या आना है, आपके पेपर में यू आर गोना गेट question 2 either for titration or rate of reaction experiment or temperature change experiment. These are the 3 questions. Number 1. Then for question 3, that's always salt analysis. The test for anions, cations, gases, and whatnot. And then question number 4, you get your experiments. It's either salt preparation, solubilities, and figuring out percentage of air, percentage by mass, whatnot, empirical formula. It can even be electrolysis. It can even be so all the multiple experiments that you've studied throughout the course that can come in question number 4. And question number 1 is either precaution or it's chromatography वगैरह. It's either precaution or simple separation techniques. That's it. Precautions, identification of apparatus, and simple techniques. These are everything. That's everything that can come in your paper 4. Easily paper 4 has the lowest percentage weightage. I mean, it has the lowest weightage because it's the examiner said I'll only test these things. महात practice यार. टेम्परेचर चेंज वाला कौन सा है वो आप देख लोगे यार, इतने ज्यादा तो हमने किए हुए हैं थ्रू आउट. टेम्परेचर चेंज हो रहा होता है, पॉलीस्टीरीन कप याद आ रहा है सलाउद्दीन. खैर सर व्हाई डिड यू डू मल्टीप्लाई 25 डिवाइड बाय 1000 ना, तो यार डिवाइड बाय 1000 लिख लें. दिस इज मल्टीप्लाई बाय 10 is power minus 3 just means 25 divided by 1000. I was too clumsy and lazy to write divide by 1000. I didn't want to confuse you. Okay, I'll just write it 25 divided by 1000. Now fine, happy. Calculate the volume of ammonia gas measured at room temperature and pressure, RTP, dissolved in 25 cm cube of A. So, calculate the volume of ammonia, aqueous ammonia gas at room temperature and pressure, dissolved in 25 cm cube of A, and the volume of 1 mole of NaS. See, he's literally guiding you throughout. He's literally guiding you. You already have the moles of aqueous ammonia. What are the moles? How many moles of ammonia are there? Let's see it. You have these many moles of ammonia. So once you have the moles of ammonia, it's very easy to find the volume. V is equal to N times 24. So moles are 0.00755 into 24 dm cube. He wants it in dm cube. Does he want it in dm cube? Absolutely, sir. So always look at the units. What does the examiner require? Dm cube, cm cube? What does he require? So it's what? 0.181? Yeah, pretty easy, huh? Use your answers to D and F to calculate the volume of ammonia gas measured at room temperature pressure dissolved in 25 cm cube of B. So that's a good question now. I don't teach biology. I hate it. But no. Manahil, A-level bio, hopefully, my brother wants to teach it. He is a graduate from Imperial College London in molecular engineering. So probably he'll be the one teaching A-level bio to you guys. He's a legend. He got a distinction and he's more smart and he's just a genius. So he'll teach you A-level biology, but I hate it. He's doing his PhD it's a joint PhD from Caltech and Imperial College London. तो वो आपको पढ़ा देगा. उसने कहा यार मेरा दिल चाह रहा है कि पढ़ाऊं बच्चों को. No, he is certainly not 2.0. He is above me. उनका लेवल ही और है. खैर अच्छा, so now you want to figure out how much ammonia gas is there in B. Now for B, first of all, you need to know the moles of ammonia in B. Once you find out the moles of aqueous ammonia in B, then you can figure out the volume, right? So how do you figure out the moles? He's also given you steps to cater, to help you, D and F. So you have D right here, you know the volume of hydrochloric acid, and you know the concentration of hydrochloric acid. That'll help you figure out the moles of hydrochloric acid. Once you have the moles of hydrochloric acid, you also know that, aqueous ammonia, the moles of hydrochloric acid would be the same for the moles for hydrochloric acid would be the same moles for aqueous ammonia. And once you have the moles, you could literally figure out the volume of aqueous ammonia or ammonia gas, right? So how do we go about it? So HCl, we first about figure out the moles of HCl required for B. And how much is that? N is equal to CV. I don't know the moles. Concentration of HCl was 0.5, and volume that was required for HCl was how much? 34.8 divided by 1,000, because I want to convert it, What's the moles? What are the moles? What are the moles? What are the moles? Sir, mistake in part F. What's the mistake in part F? 0.0174 moles of hydrochloric acid. And then I want you to use the equation to find out the moles of aqueous ammonia. So it's 1:1, so 0.0174 moles of aqueous ammonia. इसके बाद मजे का सवाल आ रहा है, would also be there, and then it's 1:1. तो जितना hydrochloric acid के moles होंगे उतने aqueous ammonia के होंगे. And once you figure out the moles of aqueous ammonia, V is equal to N times 24. What do you get? Volume 0.0174 times 24. In part F, yeah, I know in one mole is this much, but in these many moles it's going to be 0.181. So it's not a mistake, huh? That's 0.4176. So I'll just write 0.418. Yes, you could have also done that. You could have also done that. आपने DM cube में नहीं किया. क्या DM cube में नहीं किया यार? It is in DM cube. 24 DM cube. What's wrong? What seems to be the problem? What seems to be the problem? I don't think there's any problem. Acha, you could also work around with, it's right, Shamin, thanks. You could also work around with concentration. See, he said use D and F, So in F, you had this much DMQ, and in D, you know that the concentration of hydrochloric acid that was being used for B was 34.8. Remember, I made you guys calculate a factor here? I made you guys calculate a factor here. Can you take 2.3 and multiply it with this? Can you take 2.3 in D and multiply it with 24? What do you, multiply it with 0.181? What do you get? Can somebody take the factor that you calculated in D and just multiply it with 0.181? What do you get? You should get the same thing. Well, वो असल में 0.181 को आपने round off किया ना. Do 24 multiplied by this and don't round it off, and then multiply it with the factor. You're gonna get the exact same volume. Don't round these things off. So you're gonna get the exact same volume here, right? So that's what he meant by using D and F. In D, you'd just take out the factor and then you'd multiply it with the volume right here. Lekin I just preferred to not use D and F because this was a 1-mark question. That's why that was easy, but students find this more easy. So it's literally the mark is for figuring this out, No, it's not okay, Shahir. If this is 0.416, it'll be wrong. That's why I said, इसीलिए मैंने कहा कि इसको as it is लेके जाएं, or don't round it off. Use the calculator again. Sir, how is B more concentrated? रायमा दोबारा वीडियो देख लें शुरू से. Yeah, now it's fine. चलो खुश. सही है आयशा. 0.4178 is 0.418, right? तो बस सही है ना. ठीक हो गया. So you could have also figured it out through that with the factor. Yes, you could have also figured it out by just using the factor. तो ये ट्रिक्स एंड टिप्स दिमाग में रखा करें. ये आपको कोई टीचर इसलिए नहीं बताता, उनका खुद जो है दिमागी जो क्रिटिकल थिंकिंग होती है ज्यादातर नहीं होती. शायद अच्छे टीचर्स हों, बल्कि हैं, शायद क्या हैं अच्छे टीचर्स, बट You just need to figure out things from multiple aspects, using multiple aspects. Okay, the student rinses the burette with 0.5 mole per dm cube of hydrochloric acid immediately before it is filled. Why is he doing it? Because, and he's saying, explain why the student, it's a 2 mark question, explain why the student should not rinse the burette with distilled water immediately before it is filled with hydrochloric acid. Why? We literally discussed this at the start. We literally discussed, because what would happen is, if he fills it immediately with dilute hydrochloric acid, what would happen is that some water molecules may have been left inside the burette. Some water molecules or water droplets may be left inside the burette. That's only one point. What about this? Explain it. So what's the problem with this? So this would make the hydrochloric acid diluted. So the hydrochloric acid would get diluted, right? And once hydrochloric acid is diluted, the volume of neutralization would increase or decrease. The volume of neutralization needed for titration, would it increase or decrease? So you could have also written this volume for titration, volume needed for titration. दिमाग खुल रहा है बच्चों का, पहली दफा टाइट्रेशन सही कर रहे हैं. Would increase. खत्म. No, why would it decrease? We literally discussed it at the start. No, 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 no. No, it wouldn't decrease, because if this gets diluted, the power of hydrochloric acid decreases. Concentration is just like power. Power of hydrochloric acid would decrease, so more of it would be required. Oh, you dumbo jumbo. Yeah. Suggest why universal indicator is not a suitable indicator to use in these titration, because you realize that universal indicator does not give you a clear endpoint, a clear color change, because it changes color over a range of pHs. It changes color. The color varies over a range, right? So it has a range of colors. So the color change is not, yes, it gives a gradual change, range of color. देखो, आप जो मर्जी अंग्रेजी लिखो, the spirit of that English should refer to the same thing. So you wouldn't get a clear endpoint. I wouldn't get a clear endpoint. Why? Because it changes color over range of pHs. So I wouldn't be able to figure it out. Can we write in gibberish? Sure. Because universal indicator would give you different colors. So how would you know that the endpoint is reached? It would sometimes be red, then goes orange, then goes yellow. आपको कब पता है कि when do you stop? When do you stop? Why does it give a color change over a range of pHs? Because it is made up of multiple chemicals and dyes mixed together. Roig Biv. Hi Avinash, what's up, kiddo? So we're done with the first question. मजा आया ये सवाल करके. And that's the second most technical question. These are the two technical questions that were asked in one was asked in 2023, and I guess this is in 2022. So these were the most technical questions that the examiner has ever asked for titration. And remember, if titration comes in your paper, the things that I said at the start, they are very important. तो ये जो शुरू में मैंने जो बातें कही है ना, the examiner will test this in titration theory, all of the things that I said at the start. So if you've missed it, please watch the recording on YouTube later on. It's at Carboxyl. That's the channel. Sir, I have already started sharing the link of your new session with students. Thanks. Woo! That's kind of awesome. Will you upload this on YouTube? Hopefully, yes, Swaleha. Acha, so you guys can give this a read and try to wrap your head around this, ये मजे का सवाल है मेरे ख्याल से. हाँ, ये this was in 2022 October November. I guess once I do these two questions with you, everything else should just be peanuts for you. खैर, इसको देखते हैं. इसमें एक नया concept है. In this question, there's a new concept that's going to be tested. This छोटा सा new concept है. Remember to go over all the precautions for titration. देखो, या titration होगा, या rate of reaction होगा, और या temperature change का experiment होगा. That's question number 2. जो enthalpy changes है ना, वो जो polystyrene कप इस्तेमाल करते हैं बहुत सारे. तो ये 3 experiments question 2 के लिए देखे. कल मैंने question 3 salt analysis आपके साथ किया था, और इंशाल्लाह परसों जो है I will do your solubilities and whatnot. What is the probability that titration will be tested? I frankly don't know. If I just go with a blatant guess, that's going to be 33.3%, because there are three questions that can be tested. It's either rate of reaction, or it's going to be temperature change, or it's going to be titration. So 33.33% for every question. So you don't want to risk it, because it's a 14 mark, 15 mark question. So it's basically almost 50% of your ATP. You don't want to miss that. So I'll give you a 2-minute break. I'll go drink a glass of water. Sir, कसम से बहुत मजा आ रहा है. First time joining your session. I swear I should have found you. This is what everybody says. Thank you very much. Thank you for the wholesome message. But this is what everybody says. काश पहले मिलते सर. इसलिए अब A levels में आ रहा हूँ ना. A levels पढ़ेंगे मिलके फिर. हैं? चलो मैं पानी पी के आया यार. पानी पी के आया. Sir, did you are so funny and fun. Thanks, Alia. I know. I was born to be a comedian forced to teach. Born to be a comedian forced to teach chemistry. सर ए लेवल अकाउंटिंग पढ़ाएं? ओ नहीं अकाउंटिंग में असल में मसला विद अकाउंटिंग इज कि हमारा दिमाग बड़ा तेज हो गया अकाउंटिंग में. सो इट्स नॉट कि I won't be able to teach it to you like I can teach chemistry for now, at least, because I think we think really fast in accounting, so we can't just go on explaining. Because मैं आपको डेबिट क्रेडिट क्या सिखाऊं, मुझे बस आपको पता होना चाहिए कि कैसा. अब हम ऐसे कहते हैं आपको पता नहीं है कि कैश डेबिट है. you know so it's just muscle memory. So it has become muscle memory, and so when you teach things through just muscle memory, it becomes difficult. Gulana the goat. Wow. I found you 2 years ago, too short of a time. चलो मैं पानी पी के आया. ओरे साजना तू जो ना मिला जाऊंगा कहाँ. तेरे प्यार में दिल हार के. मैं मजा आया वैसे पहले सवाल का. मजा तो आया होगा यार. अच्छा. सर दुआ करें अल्लाह वाईफाई पर हम करें. आई एम स्केर्ड नाउ. ज़रा जस्ट वॉच द रिकॉर्डिंग लेटर ऑन अगेन. बस ये 2 सवाल भी देख लो, फिर खुद प्रैक्टिस कर लो. इट्स मोर देन एनफ ज़ारा. ये 2 सवाल बहुत ज़रूरी है. मैंने क्या पाया, क्या गवाया, तेरी यादें. ओके. हे चिल 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 चिल. मेरा दिल नहीं टूटा. सर वेयर डिड यू डू योर बैचलर्स फ्रॉम? I came directly into the field of chartered accountancy, so there's no bachelor's. I work at PwC. हाँ. सर सिंग इन पंजाबी. वो कौन सा एक पंजाबी का गाना था, क्या था यार. आई फॉरगॉट व्हाट वाज दैट सॉन्ग. कि ना छेड़ तैनू छेड़ के लगा के रखिया, किते वख ना हो जावी मैं तो तू, ते तो सांझी ना 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 ना. तू जाननी में जान तैनू देना, गल संग वाली सारी मैं मिटा देनी आ. फोटो दिल ते को निच जो लुका किसी बिरखियां विच, अखां दे सामने कढा देनी आ. ਤੱਕਦਾ ਹੀ ਜਾਵਾਂ ਐਨਾ ਤੈਨੂੰ ਚਾਵਾਂ, ਨਜ਼ਰਾਂ ਤੇਰੇ ਤੋਂ ਨਾ ਹਟਾਵਾਂ ਮੈਂ, ਤੇਰਾ ਇੰਜ ਸ਼ਰਮਾਉਣਾ ਅੱਖਾਂ ਵਿੱਚ ਕੋਣਾ ਤੇਰਾ, ਨਾ ਮਰ ਜਾਵਾਂ ਮੈਂ. Okay, I don't know. ਤੂੰ ਜਾਣ. Sir, what are your thoughts on KPMG? No comments right now, but it's सारा सफारशी काम. पाकिस्तान की PMG at least. खैर ये रिकॉर्डिंग में आ जाने हैं. यू शुड डू ऑडिशन फॉर व्हाट. कौन मेरा ऑडिशन लेगा? ओके. थैंक्स गाइस. वैसे आई नेवर थॉट माय वॉइस वाज दैट गुड. चलो कुछ पश्तो बाद में देखेंगे. लेट्स डू दिस. केपीएमजी इज इन अ बिग फोर अकाउंटिंग फर्म. जैसे पीडब्ल्यूसी है, लेकिन पीडब्ल्यूसी इज एट द टॉप इन एश्योरेंस पूरी दुनिया में. केपीएमजी. वी लाफ एट द फेस ऑफ केपीएमजीएंस. खैर, सोल्यूशन के इज एन aqueous solution of sodium hydroxide. वापस आ जाएं, वापस आ जाएं, वापस आ जाएं, वापस आ जाएं. It's an aqueous solution of sodium hydroxide. A student determines the concentration of solution K using a method which involves titration. Okay. If he wants to find out the concentration of solution K, he would obviously need what? Now the thought process should start working. He would need a known concentration, and preferably of an acid, because in our course it's only acid-based titrations. So एक acid होगा, उसकी known conc होगी, titration से he would find the volume of neutralization, and from the volume of neutralization or the volume for the endpoint, he'd find the moles of the acid, use the equation to find the moles of K, and then use the moles of K as well as the volume right here to figure out the concentration. Yeah. Now he says the student measures 25 cm cube of solution K using a pipette. The student makes up the solution to 250 cm cube with distilled water, right? So he's poured distilled water in it. This is a very redox titration is not normally tested. If it is tested, he will give you all the information, but it's not in the course. Khair, सुनिएगा, this is a very crucial point that you need to look at. मेरा सवाल आप लोगों से ये है कि let's suppose I take 2 moles of K and I add it to 25 cm cube of K. Will the concentration, will there be a value for concentration? N is equal to Cv. You're going to get a value for concentration, right? And then I take the same 2 moles of K and I add it to 250 cm cube of K, नहीं लिखना चाहिए, 25 cm cube of K लेके इसमें ये 25 cm cube of K, and now I have 250 cm cube of solution. इसको 25 cm cube of solution कहने हैं, जो कि K है in this case. And now in the same 25 cm cube I added more water to it. मेरा एक सवाल है, इसकी concentration और इसकी concentration में कितना फर्क होगा? इसकी concentration और इसकी concentration में फर्क होगा. Calculate both the concentration, please. Can you guys calculate can you guys calculate both the concentration? That's going to be different. Concentrate N is equal to Cv here and N is equal to Cv here. That's going to be different. But my question to you guys is, what if you take a glass of ruafza? What if you take a glass of ruafza or tang or jami shirin or whatever, and you put 2 tablespoons in 25 cm cube of water, right? In 25 cm cube of solution. And then you take the same glass, or you take a different glass, nobody cares, or you take a jug, and this jug has 250 cm cube of solution. And now you add the same 2 tablespoons of ruafza in it. My question to you guys is, yes, it's 10 times more concentrated. So realize कि volume और concentration का बड़ा close relationship है. If the volume of solution is increased by 10 times, the concentration would literally drop by 10 times, right? अच्छा, मेरे एक सवाल है आप लोगों से. If I add 2 tablespoons to 25 cm cube and 2 tablespoons of ruafza to 250 cm cube, will the concentration be different between the two? Absolutely it will, right? The concentration would be different. It would be 10 times less concentrated for 250 cm cube than for 25 cm cube. But my question to you guys is, would the tablespoons be different? 2 tablespoons in this part and 2 tablespoons in this part. Are the tablespoons that you added, do they change? No, they're the same. You added 2 tablespoons in the first one and 2 tablespoons in the second one. Similarly, if I take 2 moles of K and add it to this and 2 moles of K and add it to this, I know that the concentrations would be different. But the moles of K that you added, would that change? Would the moles of K that you added, would that change? No, it would not. So I could safely say that the moles of K that you have in 25 cm cube would be exactly the same as the moles of K that you are going to have in 250 cm cube. Can I say this? That's the new concept here. That's one thing which students tend to turn a blind eye to, और teachers भी बस कहते हैं रट्टा लगा दो. ठीक है जी. तो खैर अब ये इधर इस्तेमाल हो रहा है. मेरा एक सवाल है. The student measures 25 cm cube of solution K using a pipette. The student makes up the solution. So he's adding, more water and water to it to make up a solution of 250 cm cube. My question to you guys is, do the moles differ in both cases? Do the moles differ in both cases? No. The moles of K in 25 cm cube of solution and in 250 cm cube of solution would be the same. The concentration would be 10 times, the concentration would be 10 times more in 25 cm cube than in 250 cm cube. Or you could say it would be 10 times less than in 250 than in 25. So concentration changes, but the tablespoons that you added at the beginning, that's the same. Achha. Explain why a pipette is used instead of using a measuring cylinder to measure 25 cm cube of K. Why is a pipette used? Because it's more accurate, because of its accuracy. So because of its accuracy, or it's more accurate and whatnot. Name the container in which solution L is made. So solution L is basically 250 cm cube, and 250 cm cube के लिए हम क्या इस्तेमाल करते हैं? We use a volumetric flask, it's a huge flask. Absolutely, Shahir, you're right. So moles isn't affected by dilution of concentration. Yes. So name the container. So that's volumetric flask, Volumetric. क्या spelling है volumetric की? E है? TRIC flask. I couldn't care less, to be very honest. To be very honest, I don't know, something's happened to my hand. I've been so tired. It can't be, a beaker, because beakers aren't used to make solutions. Volumetric flask is used, and you should have watched the ATP recordings, or 15 choti recordings. When you want to make a solution, Shamir, or when you want to store a solution, you use a volumetric flask. Conical flask nahi yaar. Volumetric flask can hold up to 250 cm cube, because conical flask can't hold up that much. Usually what we do is we use a volumetric flask to make solutions. That's just yeah, because it can hold up to that amount, that volume. Here, a pipette is used to transfer 20 cm cube of solution L into a conical flask. The pipette is, some of you might think, oh, 20 cm cube. So a pipette can't, a pipette can't measure more other volume than 25 cm cube. What is going on, sir? How? Yeah, realize that there are multiple pipettes. You could make a 20 cm cube pipette, a 25 cm cube, a 5 cm cube, a 7 nano cube, what, 7 nano cube, whatever. You could make a pipette for whatever volume you want, but realize that it's just going to measure that fixed volume, that one volume. It's just going to have one graduation on it, right? Because when you start to work with bacteria, if you go into molecular engineering, you start to work with bacteria, you have nanopipettes, right? So it can absolutely measure 25 cm cube, no need to worry about it, but realize that this pipette can then only measure 25 or 20 cm cube. अच्छा वो कहते हैं a pipette is used to transfer 20 cm cube of L into a flask. The pipette is washed out before measuring solution L. अच्छा वैसे solution L क्या है? That's basically 250 cm cube बना K का, इसको dilute किया और अब इसमें से 20 cm cube निकाला. Remember, write it for yourself. What is L? L is basically what? Sodium hydroxide. What was K? K was also sodium hydroxide, because you may, get a little, what's it called? थोड़ा सा brain fog कभी कभार हो जाते, तो इसलिए लिखा करें. That's sodium hydroxide. Here, the pipette is washed out before measuring solution L. Identify the liquid that is used to wash out the pipette. What is the liquid that is used to wash out the pipette? Yes. Oh no, no, oh no, oh no. It's the same. It's sodium hydroxide, solution L. It's the same solution L. Why? Solution L. You could say that it's distilled water followed by solution L as well. You could say it's distilled water followed by solution L. Why? Because you want to figure out the concentration, right? And if you want to figure out the concentration, if you wash this with, logically socho, if you wash it with distilled water, there may be some water droplets that may be left behind. And if they are left behind, then that would dilute the concentration of solution L. So you also have to wash it with solution L before you take 20 cm cube out of it, So it's solution L. So in order to ensure that the concentration of solution L is not diluted, the student adds 2 drops of methyl orange to solution L in the remember, solution L is what? It's sodium hydroxide. And in conical flask, remember, what's in conical flask? In the conical flask, you have solution L, but that's only 20 cm cube. Please write it for yourself step by step. So when he added methyl orange gives you a yellow color in an alkali and a red color in an acid, right? Acidic solution. So it's yellow, obviously, because sodium hydroxide is an alkali. And why does he place it on a white tile? To observe the endpoint more clearly or more accurately, or to observe the color change more accurately, right? So you could write whatever. That's up to you. To see the color change more clearly, whatnot. So he says the H2SO4, the student then fills up the burette with this much sulfuric acid. The concentration of sulfuric acid is given, and he's saying it's added to the flask until there's the color change. When we know when there's a color change, that means the endpoint has been reached and you need to stop the titration experiment. Then explain why the conical flask is placed on a white tile. Why? Because to observe the color change more accurately or more clearly or whatever. इतना टेक्निकलिटीज में ना जाए. मोर क्लियरली, मोर एक्यूरेटली, ठीक है जी, accurately, to observe the end point more accurately. याद रखिए, the marking scheme that's provided to you guys, that's very refined. आप देखेंगे एक ही सवाल होगा, एक साल एक marking scheme में लफ्ज होंगे, दूसरे साल दूसरे होंगे. As long as the spirit of the answer is the same, it's fine. कोई मसला नहीं. And you use scientific terminologies. Khair, state the color change of methyl orange indicator at the end point. So at the end point, it goes from yellow to what? It goes from yellow to red. Now, some of you guys may say, oh my God, sir, it goes from yellow to orange. Okay. Practically speaking, orange, methyl orange, why do we call it methyl orange? Because at pH 7, it's orange, right? But you also need to realize that practically, it's very difficult to get that orange color. It's very, because the color change that you observe is because one drop of acid is in excess. इसलिए तो वो आपके पास red convert हो जाते. Even one drop of acid which is in excess makes the solution go from yellow to red, right? To realize that practically as humans have that there's this error, and you'll perform all of these. Yellow to orange लिख सकते हैं, लेकिन it's practically speaking it's red, and you'll perform all of these experiments later on in A levels. खैर, अभी तक हमारे पास डेटा क्या है? प्लीज राइट इट फॉर योर सेल्फ. इफ यू स्टार्ट टू फॉरगेट थिंग्स, राइट इट. अभी तक डेटा क्या है? डेटा है कि हमारे पास सोल्यूशन एल है, सोडियम हाइड्रोक्साइड, दैट्स सोल्यूशन एल, एंड आई टुक 20 cm cube into a flask, right? And then I also titrated it with what? With how much? What is the volume? What is the concentration of sulfuric acid? I titrated with this much sulfuric acid. Realize this, right? That's this. And then from the experiment, I'll figure out the volume of sulfuric acid. Because a measuring cylinder can usually it cannot hold up to 250 cm cube of solution. Yeah? ठीक है जी. That's why you use a volumetric flask. खैर, the student does 3 titration. The diagrams below show. So अब इस पूरे experiment से I'm gonna get what? I'm gonna get the volume of neutralization or the volume for endpoint. Done. बस आखिरी आखिरी सवाल करने लगा हूँ, ये आखिरी है. ओके, सो फॉर द फर्स्ट टाइट्रेशन व्हाट इज द इनिशियल ब्यूरेट रीडिंग? 0.0 right here, and then 23, 23.1, 23.2, that's 23.2, and let's just figure out these first. 24, 24.1, 24.2, that's the initial one. 24.2, 24.2, yeah, yes. And the final is 46, 46.1, 2, 3, 4, 5, 46.5. And then this one is 10, 10.1, 10.2. And then 32, 32.1, 2, 3, 4, 5, 6, 7. 32.7. 0.7 है, 0.8 है. 0.7 है यार, 0.8 नहीं है. सलाउद्दीन, क्या हो गया? 0.7. खैर, अच्छा sir, how do you know it's 0.1? Kill me. How do I know it's 0.1? See, from 9 to 10, चलो आपके लिए कर रहा हूँ क्या यार? From 9 to 10, how many graduations are there? How many graduations are there from 9 to 10? 10 ग्रेजुएशन इज एक लाइन को कह रहे हैं, 1 2 3 4 10 ग्रेजुएशन है. From 9 to 10 there are 10 readings, right? 10 graduations, and 10 graduations represent what? 9 to 10, so it represents 1 cm cube, right? 9 to 10, ये देखो 9 cm cube है 10, so 9 और 10 के बीच में 1 cm cube represents 10 graduations. So 1 graduation would represent how many cm cube? X. 1 divided by 10, x equal to 0.1. So that's actually a good question, but you could do it through trial and error as well. Here, what's the volume of hydrochloric acid used? Just subtract the two. 23.2, 23.2, 22.3, thank you, and then that's 22.5. Done. Now, what are the best titration results? Remember, the two results which are closest to each other are the best titration results. We call them concordant results. Concordant results are the best results. The results which are within 0.2 cm cube of each other. Like normally speaking, even if they are not in your question, even if they are not within 0.2 cm cube of each other, do you have to know this concordant? Yes. But you need to realize कि इन दोनों में से जो दो 0.2 cm cube within 0.2 cm cube of each other हैं, वो आपके concordant results कहलाते हैं. But also realize one more thing, even if they are not in your question, even if they are not within 0.2 cm cube, you will find out the two readings which are closest to each other. Because what happens is, एक titration जब हम करते हैं उसको हम rough titration कहते हैं, तो वो हम तेजी से करते हैं. फिर दो titration थोड़ा हल्का हल्का होके कि हमें पता लग जाए कि यार किधर टैप तेज करना है, किधर टैप स्लो करना है, right? So one is 23.2, that's 22.3 and 22.5. So these are the two closest to each other. 23.2 है यार, these are the closest to each other. So I'll put a tick here and put a tick here. And then use the titration to calculate the average volume. The average volume is what? 22.3 plus 22.5 divided by 2. Sir, 22.4 आता है, if I'm not wrong. 22.4? Ore sajana. Acha, what is this 22.4? Write it for yourself. It's the volume of sulfuric acid. Now I've written my data for myself. The data was I knew that I have this much concentration of sulfuric acid. I also found out the volume. And from this, I'd calculate the moles of sulfuric acid needed for 20 cm cube of NaOH. So स्टूडेंट्स गेट कंफ्यूज बिकॉज ऑफ अ लॉट ऑफ डेटा. तो टाइम टू टाइम अपनी लिए डेटा लिखा करें कि क्या किया है मैंने और क्या कर रहा हूँ आगे. कैलकुलेट द नंबर ऑफ मोल्स. एन इज इक्वल टू सी वी. मोल्स कितने हैं सर निकालने हैं. कॉन्सेंट्रेशन क्या है 0.1 मल्टीप्लाइड बाय he's even given it to you. He's been nice enough to give it to you here. And multiply by volume 22.4 divided by 1000. Why divided by 1000? Because see, that's in cm cube and you want it in dm cube. So divide by 1000. Right? What do we get? ये क्या फाइंड कर रहा हूं मैं. व्हाट आर दिस आर द मोल्स ऑफ सल्फ्यूरिक एसिड. प्लीज राइट इट फॉर योरसेल्फ. एंड नाउ 0.00 कितने जीरोस हैं. 0.00224. दीज आर द मोल्स ऑफ सल्फ्यूरिक एसिड. So now once I have, देखो अब मेरे पास क्या क्या है. I have the moles of sulfuric acid and I also I have the moles of sulfuric acid. Now I could use the moles of sulfuric acid and the equation to find the moles of NaOH. So see, he's going to give you the equation in the next step. So he's saying use the equation to calculate the moles of NaOH in 20 cm cube of solution L. So I know that 2 moles of NaOH react with 1 mole of sulfuric acid. So 2 moles of NaOH. Can you guys see the screen? It's glitching for me. 2 moles of NaOH react with 1 mole of sulfuric acid, and I can't see it. I'm just writing blindly now. And so how many moles did I calculate here? 0.00224. So 0.00224 would react with how many moles of sulfuric acid and cross multiply. What do I get? These are the moles of NaOH. It's probably going to be half of this. 0.00112. 0.00112. Done, sir. Done, sir. सही है. 0.00112 ये 0.00448 है. यार देखो अब आपकी वो है ना. सॉरी माय बैड. ये मैंने भी गलत लिखा है. मैंने इधर लिखना चाहिए था इसको. That's NaOH and that's H2SO4 and I have the moles of H2SO4 which is 0.00224. लकीर के फकीर बस लिखी जा रहे हो. देख कोई नहीं रहा. Cross multiply. What do you get? 0.00448. And that's the moles of sodium hydroxide in 20 cm cube. Sometimes marking scheme has orange for acid, red लिख लें, orange लिख लें, कोई फर्क नहीं पड़ता, लेकिन red is the correct term for it. Stick to your concepts. जो teachers ने पढ़ाया उसको stick to that, right? So that's 2 moles of NaOH react with 1 mole. And how many moles do I have? Sulfuric acid. These are the moles. Acha, now I can calculate the number of moles of NaOH in 250 cm cube of L. Ab dekho, I know that 0.00448 moles, these are the moles of NaOH, right? So 0.00448 moles of NaOH were in how many moles? Were in how much volume? That was in 20 cm cube. So in 250 cm cube, how many moles would I have? How many moles would I have? N or X? Doesn't matter. Cross multiply. N is equal to 0.00448 multiplied by 250 divided by 20. कितने मोल्स आ रहे हैं? 0.056 and 056. These are the moles. Sir, what if I write in standard form? Is it correct? Yes, Saliha, it's absolutely correct. अच्छा कोई बच्चा पूछ रहा है सर वुडंट इट रिमेन्स द सेम. फातिमा दैट्स अ गुड क्वेश्चन. फातिमा सिंह सर ऊपर तो आपने इतनी लंबी चौड़ी आपने टेबल स्पून की बातें की ये की और अब आप कह रहे हैं कि मोल्स डिफरेंट. देखो मोल्स आर वाई डिवाइड बाय 20 बिकॉज 250 मल्टीप्लाइड बाय दिस एन मल्टीप्लाइड बाय दिस एंड देन व्हाटएवर इज बीइंग मल्टीप्लाइड डिवाइड्स देयर. This much was in 20 cm cube and then 250 में कितने moles होंगे and cross multiply. Okay, let's answer Fatma's question. Fatma said, sir, you said that the moles would be equal. Here they're changing. No, Fatma. I said, Fatma, let's go back. I said that the moles in 25 cm cube of K and 250 cm cube of solution, right? So in 25 cm cube of solution and 250 cm cube of solution would be same. I never said that they'd be same in 20 cm cube of solution. Sir, I divided by 250 by 20 by and then हाँ आपने factor निकाल के किया. शामीन बिल्कुल सही है. शामीन sir, I first took 250 divided by 20 and then multiplied it. तो ठीक है factor करके कर लो कोई फर्क नहीं पड़ता. तो फातिमा, what you need to realize is that 250 को भी further मैंने इस 250 से further मैंने कितने निकाला था? I took out 20 cm cube out of this 250 right here. So first of all, when I took where did it go? So I took out of this 250, I further took out 20 cm cube. तो अब इनके तो मोल्स डिफरेंट हो गए ना, इस 250 में जितने मोल्स होंगे और इसमें से आपने 20 निकाल लिए सिर्फ, तो अब इसमें तो कम मोल्स निकलेंगे. So then I worked my way back to this, and now from 20 when I went to 250, now these two would be equal. These two are equal, not this and this. You know, Fatma, makes sense? Because you took it out of this. इसमें तो आपने सिर्फ और पानी डाला, इसमें से तो मैंने सिर्फ इतना ही निकाला. You know, so it would be different. Khair, reduce the number of moles of in 25 cm cube of solution K. I know that number of moles in 25 cm cube of solution K is going to be the same as the number of moles in 250 cm cube of solution L. So what is that? That's 0.056, the same. Make sense? Calculate the concentration of solution K in mole per dm cube. So now we have the moles of solution K. You know, then these are the moles of solution K. So now I just need to find out the concentration. N is equal to CV. We have the moles of solution K, and we also have the volume of solution K, which is what? 25 cm cube, but divide by 1000 to convert it into decimeter cube. What do you get as the conc? Sorry for my pathetic writing. Sorry. Oh, 2.24? 2.24. See, the concentration changes. A different student does the same experiment using 20 drops of methyl orange instead of 2 drops of methyl orange. And that's not good. Because, and he say methyl orange is acidic. उसने आपको बता भी दिया कि methyl orange जनाबे वाला is acidic. So if methyl orange is acidic, go back to your experiment and think what's happening. From the top, you are adding what? H2SO4. You're adding H2SO4 from the top. You're adding the acid from the top. And at the bottom, in the conical flask, you have the alkali, right? Now, I'm saying when you added 20 drops of methyl orange. You added a lot of methyl orange, right? And he's saying methyl orange is acidic. So if methyl orange is acidic, can I safely deduce that this methyl orange would actually neutralize the alkali? This methyl orange would actually neutralize some of the alkali. It would neutralize some of the, because acid-base reaction would take place, some of the alkali. तो अब मुझे आप एक बात बताएं, if this would neutralize some of the alkali, would you require more acid or would you require less acid to neutralize the alkali? More acid or less acid? Obviously, now the volume of acid that would be required would be smaller because some of the alkali has already been neutralized. So it's very much common sense questions at this point. So he's saying state the average titration volume is smaller, larger, or unchanged when 20 drops of methyl orange are used. So it's smaller. And why is it smaller? Because, and that's the same explanation. It doesn't matter. The English doesn't matter as long as the spirit is the same. Because the methyl orange neutralizes, but you need to use the correct key terms, right? You know, the methyl orange neutralizes some of the alkali in the conical flask. CF in the conical flask. Khatam. Therefore, you could say, therefore, not much volume of sulfuric acid would be needed. How can an indicator neutralize an alkali? Well, I didn't even know that, Ibrahim. The examiner just said it's acidic. So if it's acidic, it's going to neutralize the alkali. Who said it's neutral itself? It's acidic. वो उसने आपको बता भी दिया. अब आप एग्जामिनर को क्वेश्चन कर रहे हैं, वो कैम्ब्रिज की PhDs बैठे हुए हैं. Sir, I found an insect next to me. Kill it. Cambridge की PhDs बैठे हुए हैं. अब वो अगर आपको कह रहे हैं कि methyl orange is, and that's the fun fact. I knew it before, but I'm just saying, even as a student, if I were a student doing this question, I'd say I don't know it, right? But he told me that it's acidic. I just deduce whatever common sense prevails here. So what the common sense that prevails here is that if it's acidic, it will neutralize some of the alkali. That's why देखो रट्टे ना मारी चीज़ों पे. Use logical reasoning कि अच्छा अगर ये acidic है तो ये तो कुछ ना कुछ इस्तेमाल कर देगा तो कुछ ना कुछ ये IGCSE वाला पेपर क्यों इतना easy होता है? Arshman, this is not IGCSE. This is O levels. ये लो. Fun fact. And these were actually the most difficult questions of titration that had ever been tested. और बाकी सारी यही हैं, देखो इसी को रेपिटेशन, अच्छा खैर ये तो एग्जैक्ट सेम इधर कॉपी हुआ हुआ है, ये एग्जैक्ट सेम रेपिटेशन है. A student investigated aqueous sodium carbonate dilute hydrochloric acid using two indicators blah blue blah blue. Just remember the idea. देखो इधर उसने ये सवाल भी बड़े मजे का था. इस सवाल में ये था जो ऊपर मैंने शुरू में बातें बताई थी ना, the things that I told you guys at the start, कि why do you wash it with hydrochloric acid. देखो, so compare the concentration, you take out the factors between their volumes, blah blah blah, blue blah blah, blue blah blah, blah blah blah, blah blah blah. Pretty easy, you know. देखो, explain why the conical flask was rinsed with water. Explain why the conical flask was not rinsed with solution L in experiment 2. Remember, I said that even if you don't wash the conical flask, the idea is that the acid would only react with the particles of the alkali and not with water. So even if water droplets are present, it doesn't make a difference. Yes, why was it rinsed with water? To remove impurities from experiment number 1. Because at start of experiment, that's one. तो बड़ी सिंपल चीज़ें, मैंने दो सबसे मुश्किल सवाल आपके करा दिए. इसके बाद now what I'd recommend to you guys is that this was a very fun class for me too, because obviously I saw a lot of students struggling with these questions still. That was fun to see you guys still struggle, but I enjoyed it, but you all need to just do more topic. देखो, keep on doing topic wise questions for the ATP until you get confident doing that question. तो titration कल रात को मैंने कहा था salt analysis खत्म कर लें. So I hope you all have done salt analysis yesterday after my live class, and now I hope that you guys sit for titration questions and you just start butchering those titration questions, demolishing them one by one, until you get confident, right? And once you get confident, तो ज़िंदगी बड़ी आसान हो जाएगी. और कल इंशाल्लाह hopefully I'm gonna conduct the class for what's it called यार, I'm gonna conduct a class for question number 4 hopefully. मेरे जो ATP booklet है MS, you can purchase the MS because that's my ATP topical booklet. तो पोर्टल का एक्सेस दे दीजिएगा, वरना तो आप खुद जो ईयरली बुकलेट है आपके पास, व्हाट आई रिकमेंड, और खाली तो बुकलेट मेरी अवेलेबल है और सामने ये, इसके सामने ये लिखा हुआ है, तो बस कोड भी लिखा है, पेपर भी लिखा है, तो आफ्टर यू सॉल्व अ क्वेश्चन जस्ट गो ऑन टू द कोड, यू डोंट नीड टू परचेज द एमएस. And then we should do the questions in this booklet. Yeah, you could do that, and just do, and what you guys could also do is take your yearly booklet and just do topic wise questions. So go to question number 2s of your yearly booklet. I cannot find the ATP videos mentioned, or no, they're available on the portal, Junaid. They're just 2 to 3 minute videos of, that's just for question number 1. 2 or 3 minute videos for question number 1, which contains separation techniques and what's distillation and fractional distillation and whatnot. Can I upload this onto YouTube? Absolutely, I can, and I will. I'll upload it right now. In fact, I'll do it right now. I'll pause this. I'll